Yes? Okay. So I'm going to talk about Python. I'm actually going to assume that you don't already know everything about Python. Hands up who is already a Python programmer, who is using Python? Okay, a few. Who would like to learn how to use Python? Also a few. This talk is for neither categories because I'm not giving a tutorial, but I'll talk about all sorts of stuff. What is it if you've never heard of it before? Where did it come from? How did I create the language? Where are we today? What Python implementations exist? What are we going to do in the future? And I already have a whole bunch of questions. Feel free to send me more. So what is Python? I'll start by a quote, and you'll notice that is someone who is involved in YouTube. YouTube is actually, for a large extent, written in Python. Almost all of YouTube is written in Python. And you know YouTube is one of the fastest video surfing websites in the world. So I actually got a quote out of them, and they said, Python is fast enough for our site to allow us to produce maintainable features in record times with a minimum of developers. Now, if that's not a good enough reason for you to start developing your next application in Python, I don't know what could get you over the cliff. So in more detail, Python is a general programming language. It is of the dynamically typed and object-oriented category. It is also compliant with 99% of all buzzwords. One of Python's important philosophical points is that it is an easy language to read. It fits in your head. It is not a large language. Of course, it has a large library and it has a large area of applicability, but the language itself is relatively small, which makes, and also relatively regular. There are not a lot of special cases in the language, which makes it easy to learn the language. You can learn a few things and already be very productive. It also makes it very easy to read the language. If you don't know all the features of the language, when you read a piece of code that uses a feature that you haven't learned about yet, you can probably still understand what it's trying to do, and maybe you learn just by reading. It's also easy to write. That doesn't necessarily mean the minimum number of keystrokes. It does mean that it's easy to write correct code. It's not so difficult to figure out how to write a particular application. All these things make it easy to use and easy to maintain. Someone once said that Python is executable pseudocode, so I thought I threw that in. Python is actually fairly mature. I started developing Python about 17 or 18 years ago, depending on how you count. The first public release was in 1991, well before Java. Now, if you wonder why Python is not more popular than Java, that's because I have a $0 PR budget. Python has always been open source from before the term open source was invented. The term Python is actually trademarked by the Python Software Foundation. We have never done something with that trademark except note it on our website, python.org, so that people know that if they use the name Python, they're supposed to respect the integrity of the language. They cannot sort of take Python, remove half of the functionality, add a bunch of proprietary stuff, and then still call it Python, for example. We would definitely write down the cease and desist letter. There's a list, TIOBE, I don't even know what it stands for, but it's a group of people who collect statistics. I think they actually do a bunch of clever Google queries to try to figure out which programming languages are popular. And they do that every month or so. And Python is number 7 on that list, and you can guess who else is higher ranked, like C++ and Java. I think Perl is number 6 and Visual Basic is somewhere there too. So Python is quite a popular programming language. Who is using Python? Well, it's already very clear that Google uses Python. Lots of other companies and organizations use Python. All Google's competitors use Python. Everybody uses Python. You guys should use Python too. So what can you do with Python? What are typical application areas? Again, it's a general programming language. You name it, people have used Python for it successfully. It is definitely, you can use it very well as a traditional scripting language, meaning system administration scripts, data conversion scripts, all sorts of one-off things between 30 and 300 lines or so. If you want to, you can grow to 3,000 lines, of course. It's a very good language for rapid prototyping because you can write a lot of functionality in a small number of lines of Python code. If you don't exactly know what you want your application to do or how to do it, you can quickly cook up something in Python and run it and see if it works right, especially for interactive things or websites. You can very quickly change features in the Python code and try again. So Python has been used in many times for web applications. There is probably several dozens of web frameworks for Python. The most popular ones are things like Django and TurboGears. There's also Twisted, which is a more generic, more mature, but also more lower level networking package. There's Zope, which is a content management system, also quite mature. And many more that I've never even heard of. At the moment, I should say my current favorite web application framework for Python is Django. And I think that both Django and TurboGears are pretty much on a par with Ruby on Rails in terms of functionality and performance feature set. An interesting application area for Python is scientific computing. That's why NASA was on that list. A couple of other big government labs in the US and lots of universities that do lots of scientific data processing use Python. There are many third-party libraries that tie Python to existing number crunching libraries or numerical data manipulation libraries, visualization, plotting, graphing. I've heard of quite a few people who use Python as a free replacement of MATLAB, which is a very expensive commercial application. I think in the US it's like $700 per seed. And Python is almost as good for $0 per seed. So the final application I want to sort of focus on just a tiny little bit is education. Python is used quite a bit for introduction to programming courses because the language is so simple to type and so simple to read, you can really focus on the concepts. What is a loop? What is a data structure? What is an array? What is a function? What is a class? What is an object? Rather than students having to struggle with where to put the semicolons, get the lining of their curly braces, getting the types of their parameters correct, and memory allocation. For example, the One Laptop Per Child project, which is hoping to build a laptop that will cost $100 and can be sold to third world countries and probably also to China if people are interested. For use in schools, uses Python a lot, both to write educational applications but also to teach students programming when they grow up. So I said I won't try to teach you Python, but I'd like to give you a little bit of a flavor of what Python code looks like. So one thing to notice is that Python doesn't have a limitation on the size of numbers. We can print 2 to the power of 100, which definitely does not fit in 32 bits because you know it's going to fit in 101 bits. Converts this to decimal and prints that just fine. You can use smaller numbers too if you want to. Let's define a very small function hello. It takes 2 parameters. One is a name and one is a number. The number has a default value which equals to 1. There's a little comment there, greet your name n times. Then indented, there's a loop that goes around the n times, and each time it prints hello and that name. So we call hello Beijing, and it will print it once. It will say hello China, and it will with a second argument 2 that overrides that n equals 1 default. So that will print hello China twice. And there's actually Unicode support to some extent. You can actually type Chinese characters and get them to print out if all the stars are aligned properly. And with Python 3.0 we'll hope to improve that. There's a very large standard library. Just as a tiny example, I import a library that knows how to contact websites, URLib. We call URLib.url open. We give it the URL. We read the home page from there, just one line. And then we start counting how many times the word Google occurs in a line of Google's China homepage. It turns out that there are 3 lines containing the word Google. If you count the number of times Google occurs, that's much more, because several of those occur on the same line. Must be pretty long lines. Anyway, oh, I forgot to mention one thing. These dots here, these arrows here are the interactive interpreter prompt. Every time you type a complete command, it executes it, prints the output, and then prints another prompt that looks like this, three greater than characters. And that means that it's ready for you to type the next command. If you type an incomplete command, like if you type the first line of this for loop and you hit return, it changes the prompt to 3 dots, meaning you have to type more. So you type a few spaces and then you type the next line. And then it tells you, well, you still need to type more. It knows that you haven't finished your code yet, and so you type some more dots and you visit. Each of these indentation levels is another block of nesting in the language. Finally, what you don't see here is that here I just hit return, and then it said, okay, if you hit return without entering any new text, that means you're done, so then it executes this whole thing. So that was the micro tutorial. You can go online to python.org to find a much longer and more interesting tutorial. So I'll give a little bit of the history of the language, where I'm coming from. So, a very brief timeline. I started in December 1989. And that's when I first started typing bits of a program that would eventually become Python. I think it took several months before it would actually execute simple things like print 2 plus 2. But very soon afterwards it was actually usable, and we used it within the place where I was working, a place called CWI in Amsterdam, which is a government-funded research lab. It's a great place, by the way. And we decided, I worked on it, not full-time, but a lot of my spare time and some of my work time. And some of my colleagues also worked on it because they liked using it and they liked making it better. So in February 1991, we actually did our first public release. There wasn't much of an internet there. There were no websites. We didn't even have FTP at that time. We had to post it to Usenet, which meant that first we had to put it in a tar file. Then we had to UU encode the tar file because you could not post binary files to Usenet. Then we had to cut the UU encoded file up in about 20 parts because there was a strict posting size limitation of something like 64,000 bytes per post. And then you had to, we actually ran a little Python script that then posted all those parts to the newsgroup one at a time with numbering in the subject so that if they arrived out of order, you could tell which part was the first and which part was the second. That was an instant success, so we did more of that. We switched to more advanced forms of distribution like FTP. Somewhere in there, around 95, I moved to the United States. Got to spend much more time, got to work with a whole team of people helping me to work on Python. In the year 2000, we released Python 2.0. Soon afterwards, by the way, we came up with the idea of Python 3000, which I'll be saying a bit more about in a minute, a couple minutes. Then in 2001 we created the Python Software Foundation, which is a US-based non-profit organization that owns the copyright to the code and also has some members that actually pay money for their membership, and that way they sponsor conferences and other activities, and we pay for the hosting of the website and things like that. So we kept releasing new versions, and in 2004 we released 2.4, in 2006 we released 2.5. At some time next year we expect to be releasing 2.6 and 3.0 around the same time. By the way, I should mention that Python's name came from a British comedy show named Monty Python's Flying Circus. I don't know how many people here have heard of it or have seen movies like Monty Python and the Holy Grail. It's very funny, it's very silly. And it was absolutely not my idea to make a reference to snakes. But it was inevitable that people would start designing logos for Python websites using snakes, so I just had to accept that. So why did I come up with this silly idea of creating my own programming language? Because that is definitely something you do against all odds. Lots of people may design programming languages, but very few of those become successful. And most of the programming languages that become successful actually have commercial backing, whether it be Java or C# or Visual Basic. Two of the biggest programming languages that don't have a commercial backing directly are C++. But C++ has a lot of industry backing anyway, both from the compiler vendors and from commercial users. And Perl, which really is an open source project, much like Python. I didn't model Python after Perl, but it sort of happened around the same time and with the same idealistic mindset. So before there was Python, there was ABC. ABC was a teaching language, and it looks a little bit like Python. You can actually Google for it and find a download that you can still compile, at least on modern Linux systems, as long as you have a C compiler. And it's a cute language, and it actually uses indentation just like Python does. And it has data types that resemble Python's data types, like it has lists. It has dictionaries, except the dictionaries are called tables, and it has numbers and strings, except the strings are called texts, and it has tuples. Lots of other things about Python, about ABC are different from Python, but ABC was definitely a big inspiration for Python. I was hired into the ABC team when they had pretty much completed the language design, and they had an early prototype implementation. What they wanted to do next was create a more professional, large-scale, successful, fast, complete implementation. And they hired a bunch of people. I was one of them, straight out of college. And I had a lot of fun on that team, and I contributed a lot of code to the implementation. And unfortunately, ABC really did not go anywhere. So this is one of those examples of a great programming language that was designed and implemented and released, and nobody did a download. Well, actually, in those days, there wasn't even Usenet. So we pretty much had to mail tapes with the software to other sites in order to spread it. And maybe that had something to do with it, but I think there were other issues with the language too. And so when that project died, I joined another project named Amoeba, which was a distributed microkernel operating system. You might still have heard of that. Amoeba also didn't become sort of a big worldwide success, except in academia. It produced a lot of very relevant research papers about all sorts of aspects of remote procedure call and file system, directory service, encryption, microkernels, distributed services. The interesting thing about Amoeba was that even though it was written by and designed by a bunch of people who were very experienced Unix hackers, it was doing everything very different from Unix. And initially, the only languages that were available for running on Amoeba were C and the original Bourne shell, not the Born Again shell, not Bash, but the regular SH. So I joined that project, and it was my task, amongst others, to write application software for Amoeba so that people could actually do useful things with their Amoeba workstations and not just run benchmarks to see how fast the remote procedure call was. So I found that with C pretty much the only realistic programming language available, it took me a long time to write even the simplest application. And now for some things it makes total sense to write it in C because you need the program to run very fast, but other things are only used occasionally, like how many times in a day do you log in? Is it really necessary that it takes 1 millisecond to log in instead of 10? So I thought, well, there should really be a programming language that makes it easier for me to write code. Maybe it'll run a little slower by being an interpreted language, but it'll make my task of writing lots of different applications for that platform so much easier. So then I thought, okay, well, a couple of years ago I worked on this language ABC, and it was kind of sad that ABC was unsuccessful. Maybe I could borrow a whole bunch of good ideas from ABC and revive it under a different name on a different platform. So that's what I did. And everything that I didn't like about ABC, I changed. For example, ABC used uppercase keywords, and I really didn't like typing uppercase letters much. And everything that I did like about ABC, I copied or I modified only slightly. Like I changed the way lists and dictionaries worked a little bit, and I changed the way numbers worked a little bit, and I left strings pretty much alone, and I left tuples pretty much alone. And that's how I sort of started creating a new language that was very much a mixture of ABC and a couple of other languages that I knew, from Algol 60 and Algol 68 to C, Modulo 3, some Smalltalk, some Icon. The only language that I can promise you that I did not know enough about to possibly borrow from is Lisp, and that's very ironic because everybody says Python's sort of dynamic runtime environment is so Lisp-like except for the syntax. But that is pure like two separate threads of evolution reaching the same result because their same forces are working on it. One does not derive from the other in this case. So I had a whole bunch of design goals, but pretty much at the top was that it was my personal one-person project. I didn't have a large team. I didn't have an infinite amount of time. Actually, it was sort of, I didn't actually tell my boss, oh, by the way, I think I need to implement a new programming language. I just sort of worked in weekends, and the time I started was Christmas holiday time, when I had a lot of time off. I worked evenings, and occasionally I worked some of it in my daytime while I was also doing the rest of my day job. So within that framework of this not quite being an illegal project, but also not quite being my main job, I wanted to have quick results because I'm an instant gratification junkie. That's why Python is interactive. I want to be able to type 2 + 2 and see the number 4 appear immediately. I don't want to have to compile and link my application before I can see the results. So I also wanted my project to have very quick turnaround time. So being simple to implement was sort of almost the most important part of my goals. Then I just had a whole bunch of standard, very high-level language things that I put in. I wanted it to be cross-platform because while Amoeba was sort of nominally the reason for starting this project, I didn't want Python to be sort of to require Amoeba in order to run. So I made it so that it would run on Unix, on Mac, and on Amoeba, and later I also ported it to Windows myself, but the compilers on Windows were not very good and not very pleasant at the time. So I wanted it to be very readable, and I've already mentioned a bunch of those things. One important feature is I wanted it to be safe. A bug in the user's program should not cause the interpreter to crash. So, for example, in C, if you don't initialize a pointer and then you dereference it, you'll probably go to dereference random bits in memory, or you're going to reach outside defined memory and get a segmentation fault. I did not want that kind of stuff to happen. In Python, if you used a variable that was not properly defined, you should get an error message and a traceback, and you should be able to continue running the rest of your program. I also was quite a fan of C, so I didn't want Python to be competing with C. So I didn't care about all the things that C already did really well. I cared about the situations where C was not doing so great. I also wanted it to be possible to sort of merge coding in C with coding in Python. So I came up with the idea of extension modules, where the source code for the extension module is written in C, and these days you can also write it in C++ or in Fortran, or in Java or in C#, or probably in Visual Basic if you really want to run on that platform. But you can import it into your Python program and use it as a regular Python module. And to these days, there are people who wonder, where is the math module? I cannot find the file math.py anywhere on my file system, and yet when I say import math, it works. Where's the code for the math module? They don't realize that there are other programming languages involved in Python at all. That's actually a success story, because it means those people only know one programming language, and most of the time that is apparently enough for them. It turns out that being able to create extension modules for Python quite easily, that means you have a good foreign function interface, another way of saying that, makes it very easy to use Python to sort of glue existing C programs or libraries together. And the numerical applications, scientific data processing applications I mentioned earlier, use that a lot. Of course, if you use the web, you'll also use some of that. If you use a database, typically you link to a database library provided by your database application vendor or open source project, which is usually written in C. So again, you cross the boundary between Python and C is crossed many times in a typical Python program. So other things that Python takes care of, just like every other very high-level language like Perl or Ruby or Visual Basic. Memory management is automatic. Actually, many of these, even Java does a decent job. Not so much the next one. Python has a small number of data types that are very flexible and powerful. Instead of having lots of different data types, each with a very specialized purpose, there's a small number of very general data types, and that makes it easy to choose your data type, because you don't have to decide, oh, am I going to use a hash map or a tree map or some other kind of map. There's only one kind of map data type built into Python, even though you can write others if you have specialized needs. But usually it's very easy. I mean, there's a list type and a dictionary type, and if you think about how your data structure is going to be used, it's always completely obvious which of the two to use or how to combine them. Often you see things like dictionaries containing lists, or occasionally lists containing dictionaries. It's a virtual machine using bytecode. You can serialize your data types. So write your data to a file and read it back. Everything in the language is sort of geared towards being simple and stupid. And I definitely did not have not invented here syndrome. I'm very open to borrowing features from other languages. And in fact, I should mention that some of the things that I didn't borrow from other languages, things that I sort of invented all by myself, were some of the less successful features of Python. But of course, the trick is to borrow cleverly. I mean, you could probably design the worst programming language in the world by borrowing from exactly the same languages that Python borrowed from, but borrowing a different set of features that don't work together. So I do take full responsibility for borrowing from other languages in a way that the combined set of features works well. So some people ask me, like, okay, I meet this high-powered executive in the elevator, and between floor 1 and 22, I have the time to explain to him what is Python all about. So this might be the bullet list. So there's no type checking in the compiler. All the type checking is done at runtime. That's actually better because when the compiler loses track of a variable, you have situations where the compiler thinks that something is a number, but really it's a pointer. That can happen all the time in C or C++, and then when you run your program, it crashes. If you keep track of the data types of objects at runtime, that cannot happen, or at least the crashes are much less severe. You'll get some kind of polite traceback rather than an impolite segmentation fault. So typing is dynamic, but scoping of variables is static. The compiler does know what a variable is and whether a variable is local to a function or global to a module or things like that. Everything's an object. Every once in a while I hear people ask, comparing Python to Ruby, Ruby is more object-oriented, Python is not completely object-oriented. I don't know who invented that, because the way I think about it, Python is totally fully object-oriented. Everything is an object. Even the null object, which Python calls none, is actually an object. Namespaces, there are lots of namespaces. A module is a namespace, a class is a namespace, an object is a namespace, a function is a namespace. Introspection. Any object has a way of telling you what the properties of that object are, what the attributes are, what the methods are, what they do. There's also built-in documentation in most objects. You can ask help for a particular object, and it tells you in English what the methods of that object will do for you. The next one is sort of interesting. The Python interpreter is not particularly sort of privileged over the user. The user can do almost anything that the interpreter can do. I mean, if you see a built-in function that does a particular operation, you can also write equivalent Python code. Now, that's not always true because we stop sort of at the level where obviously a bug in the system can actually cause segmentation faults, and we don't want bug in user code to cause segmentation faults. So that's sort of where we draw the bar, but that's pretty close to being able to do lots of weird things. It's interactive. I already mentioned the interactive prompt. And one interesting thing is, in the design of the language, it's important that if there's a feature, that it's possible to implement that feature relatively easily. And that goes back to my original sort of, this was a one-person part-time project. So I want to go a little quicker. I have a couple of slides about the design process. This is what I used to keep my sanity as Python became more popular. Everybody started sending me patches and improvements and ideas, and if I had accepted every new idea that people sent out, Python would soon have been a completely random collection of unrelated features. And instead, I tried to really stay true to Python's original design goals. If people would sort of consistently come up with questions, I want this particular feature, I would much rather patiently explain how they could already implement that, either by writing a bit of Python code and putting that in a library, or maybe if it was a harder to do thing, they could write an extension module. And if there was something they really couldn't do even by writing an extension module, I would much rather add a generic feature at the sort of the extensibility level so that they could write that themselves, rather than add a one-off feature to the language. Over time, the design process has evolved a little bit. Now, because the user community is so much larger than it originally was, we also care a lot about backwards incompatibility. So if you propose a new feature and you propose to use syntax that already has some meaning, even if it's sort of a silly meaning, we'll very easily say, well, you can't use that syntax because it would not be compatible. We're also setting the bar really high so that only the best features proposed will actually make it into the language, and that sort of, a new feature must benefit many, many, many Python users before it's accepted. I've also learned from my early mistakes. and sort of, I try to not to repeat the same kinds of mistakes at least. I'd rather make new mistakes that are different than repeat the old mistakes. Another thing is things need to be readable. I already emphasized that a couple of times. So one thing is when people propose new syntax, that's one aspect of the language design where I'm still very much involved. I veto all syntax proposals unless they are really good and important. So I like new syntax to read very natural or to resemble some well-known mathematical notation or notation in other programming languages. Of course, that's highly subjective, but I mean, I like that not all programming languages are the same. These days, there's a lot of interaction with the community. There is a thing called a Python enhancement proposal. If you want to make a significant change to Python, you better polish up your writing skills and start writing a PEP, Python enhancement proposal. If you're familiar with the JSR process in the Java world or the RFC process in the IETF, it's somewhat similar, except because Python is still a smaller community, we're not quite as formal. And we use these PEPs for all sorts of things, even for keeping track of when we release what and why and how. It's not a democracy, it's also not a dictatorship. I don't have a lot of power to force people to do what I want them to do. So we discuss a lot. We don't necessarily end with a vote. We try to reach consensus. And so where is Python today? Well, I already mentioned Python 2.5 was released. Actually, Python 2.5.1 was released this year. 2.5.1 was a very minor bug fix release. I think it fixed a few security bugs and a whole bunch of very minor obscure bugs. Absolutely did not add features. And that's a typical, that's sort of by design these days. We have what you could call minor versions, 2.4, 2.5, 2.6. Those are actually the versions that introduce new features, and then there are the micro versions, 2.5.1, 2.3. Those introduce pure bug fixes. Now the minor releases, 2.4 and 2.5, are all backwards compatible with earlier versions. So at some point we'll come to a major new version, 3.0, which will break backwards compatibility. What did we change in 2.5? We added a conditional expression. So you have expression 1, if, condition, else, expression 2. There are very few other languages that put them in this order, but there are mathematicians who actually write their logical expressions like that. There's also a with statement, which is a handy shortcut for cleanup operations that otherwise you would have to write with a try except block or try finally block. Lots of other new features in 2.5. I really don't want to go into much of that. More library stuff, of course. There are other Python implementations. There's Jython, which is Python on the JVM, written in 100% pure Python. The same guy who started the Jython project and then ran away from it, also started IronPython, which is the same idea but for Microsoft.NET and actually also for Mono, so it also runs on open source. And actually IronPython itself is open source, even though it is by Microsoft. It's probably the first open source project ever released by Microsoft. And I hope it's not the last one, by the way. Then there's PyPy, which has now been completed. That was a sort of a research experiment in trying to implement Python in Python itself. Lots of very clever people worked on it. And I think that the end result was still somewhat slower than the normal Python implementation. But with a little bit more funding, they probably would have been able to make it faster because they were almost at the point of writing a just-in-time compiler. So what will the future offer? Python 3000. That's the next major version. That's the first version in a very long time that's actually backwards incompatible. It's going to be quite backwards incompatible in sort of you'd be very lucky to have a Python 2.5 program that also runs under 3.0, unchanged. However, we're going to provide a number of backwards compatibility measures. We'll have an automatic translator that changes 2.5 syntax into 3.0 syntax. And we'll also, in 2.6, we'll have a bunch of warnings that tell you you're using a feature that will not be available in this form in 3.0. So you can replace it by an equivalent feature that's already available in 2.6. So Python 3000 is really my sort of the only opportunity I have to fix some of the early design mistakes I made when I was still a very young and naive and inexperienced language designer. And many of those mistakes are kind of technical, so I won't go into much detail. Many of those mistakes have already mostly been fixed in more recent versions of Python, but often the old wrong way of doing things was still also supported for backwards compatibility reasons. So many people kept continuing to use the old wrong way instead of converting their code to the new way, because they were worried that if they used the new way, their code would not be compatible with Python 1.5 or something like that. An example of a mistake that I made was if you divide two floating point numbers, of course you get a floating point result. So 1.0 divided by 2.0 will give you a half. But if you divide two integers with the same values as those floating point numbers, it suddenly uses the C-style truncating integer division. So 1 divided by 2 is 0. That's very confusing. It can cause very, very subtle hidden bugs in programs that do mathematical calculations. So in 3.0 we changed that to returning 0.5. Obviously that's very backwards incompatible. But I think since Python 2.1 or 2.2 you've been able to write double slash for if you really need integer division. So it's quite possible to write code that is forward compatible. The biggest highlight, and I really want to emphasize this for a Chinese audience, is that Unicode, which has been in Python from 2.0 as an optional feature, is now integral to the language. All text strings are Unicode strings, and we use a separate bytes data type for binary or encoded data. And also, even more revolutionary for many programming languages, you will be able to use non-Latin characters in the alphabet for identifiers. So you can create modules or variables or classes or functions, for example, with Chinese names, or if you want to, Japanese names or French names or Arabic names. A lot of things change because of this. This is probably going to be one of the nastiest sources of incompatibility between Python 2 and Python 3, but it's definitely the right thing going forward. Other things that we're adding some minimal support for abstract base classes. So you can actually define a class like number or sequence that is the base class of all numeric types or all sequence types like lists and tuples and strings. You can specify type annotations for function parameter lists. Many things that used to return lists will now return iterators, which is more efficient if you don't use the whole thing or if you just iterate over it once. We'll have much better built-in support for the set data type, which was introduced in 2.4. What else? Oh, there's only going to be one integer data type in Python 2. Even though I showed you print 2 to the power 100 actually computes a very large number, Python 2 still has a distinction between 32-bit integers and arbitrary precision integers or big nums. Python calls those longs. So as a programmer, occasionally you have to be aware of the difference between the two, and we're taking that away. We're just calling it all int, and internally it behaves more like the old long. The print statement becomes a function. If you're familiar with Python, you might think that that's a real big mistake. It turns out that the reason why making print a function, is is somewhat subtle, but it means that if you have a program full of print statements, it becomes a lot easier to turn those print statements into calls into another library when they're all functions. And because of that, and because of the Unicode, we're rewriting the whole standard I/O library, and we're removing the dependency on the C standard I/O library. Python will have its own standard I/O library built directly on Unix or Windows or Mac system calls. So we're planning to release Python 3000. The final version of 3000 or 3.0 will be out sometime next summer, possibly around the time of the Olympics here. So I'll be too busy to watch TV, but I'll be thinking of you all. With this summer, we hope to have the first alpha out. I had originally planned to have 3.0 alpha 1 out by the end of June. I already know I'm not going to make that date. I'm thinking more of August now. At the same time, Python 2.6 will also be released around the same time as 3.0, I think a few months earlier. 2.6 will provide full backwards compatibility with 2.5, but also forward compatibility features to warn you about things that will change in 3.0. That is the main part of the talk, and now we have questions. I'm not sure how I can get through those in 10 minutes. I'll actually start with the questions that I was given during the previous, during the panel. Let's see. What is your favorite color? No. Red, by the way. .py files are plain text files. .pyc files can be easily decompiled to .py files. If you use Python to write commercial applications, there are situations that we want to protect our source code. So will you consider to create some mechanism to protect source code? Well, actually, I don't really think that that's my job. But if you really think that that's important, you can write your own tool, because you can manipulate Python source code using just Python. You can obfuscate it as much as you want to. The problem is actually similar in Java. People develop Java code commercially all the time. Number two, I'm curious about your day job in Google. Is it all related to Python? Yes. What do you do in Google? I spend half my time developing things like Python 3000, and I spend the other half of my time developing tools for Google's developers using Python and Django in some cases. I have tried stackless Python. It seems good. Will you merge it into CPython? The answer is no, because stackless Python does not translate well to other implementations of the language like Jython or IronPython, and I want those languages to be complete Python implementations. Another one. The return values and exceptions are not well documented. Why? Well, I guess that's sort of the collective deficiency of the Python community. We're more programmers and less writers. If you want good documentation, you will find that some of the books you can buy, for example, O'Reilly's Python in a Nutshell, there are a few others also, give much better documentation. So I'm sorry, but there's not really any deep reason. What applications of Google is built in Python? Well, for example, code.google.com, Google's open source portal, is all written in Python. I think as part of that, the open source code search facility is also written in Python. Internal applications at Google are written in Python all the time. External facing applications at Google are not often written in Python, but there are some experiments in the labs, and also things facing advertising vendors. What technologies make Python running faster? I would say wait a few years when the computers are faster. Or use a tool named Psycho, P-S-Y-C-O, which is an accelerator which turns at least simple Python functions into x86 machine language. and it can be quite a dramatic speed up from 10 to 100 times. But you have to be lucky, because if you make a lot of function calls or if you use objects a lot, it doesn't help much. Oh, one more about what web framework of Python do you use? Django is my favorite. Even though I'm not much of a web programmer actually, so I don't have time to keep track of all the web frameworks. So maybe TurboGears is better, or maybe something I haven't heard of is better. But I like Django very much, and I think Django is a great open source project. Oh yeah, this question is pretty much the same. What do you think of Python as a language for web development? Django or TurboGears, what's your opinion of them? The future of Python, yeah, I think we did that. What are the advantages of Python against Ruby, in your opinion? Well, Python and Ruby are pretty much equivalent in many situations. They really fit in the same niche. I mean, they're both object-oriented and dynamically typed languages. They have somewhat similar syntax. If you look at it more closely, Ruby is actually a very successful attempt at writing a better Perl and not at writing a worse Python. At the moment, I believe Ruby is much less mature than Python. I mean, it has had a tremendous success with Ruby on Rails, but that's the only web framework available for Ruby. If you don't like Ruby on Rails, you don't really have any other choices. In Python, there's always another framework and there are a couple of frameworks are actually set up as sort of mix and match frameworks. So you can use the templates from one framework with the URL mapping from another framework, and maybe the database object adapter from yet another framework. So that was Ruby versus Python. Let's see what have we got here. Does Python execute faster than Java? Oh, I wish. What about its speed comparing to Perl? That depends very much on how you benchmark it. It's probably a few fractions of a % slower than Perl, but in most of the cases it runs sort of at about the same speed, which is the speed of an interpreter rather than the speed of a compiled language. In most cases it doesn't matter, because many Python and many Perl and many Ruby programs, by the way, are I/O bound and not CPU bound. I'm not going to give more opinions on Perl. It's a great language, but I don't like their approach to syntax. I'm a student from Beijing University. I believe Python can be at least a good assistance for programmers in their daily life, but not all the students like me have seen it. Can you give me some simple persuasions on why they should choose Python? Yeah, how to convince people that they use Python? Show them examples, show them something you write yourself and how easy it was to write, and show them the code and see, this is all you need to do in order to do this particular functionality. Go find example code on the web that they can use. There's a lot of questions about Perl here. How many people here are Perl users currently? Oh, okay, so they all stayed away. They asked questions, but they... I mean, Perl is a perfectly fine programming language if you don't have to ever perform much maintenance of your code. I mean, the typical situation is a clever programmer A writes a Perl script to do a particular thing. And 6 months later, somebody who is a user of that program needs a new feature added. Even the person who wrote the program will be quicker to rewrite the whole thing from scratch with the new feature added than modifying the existing Perl code to add the feature. In Python, you can actually modify the existing code because you can still read it even if you didn't write it yourself. So that's what my view on Perl is, and Google agrees with that. only supports use of Perl internally for very small scripts. What's your favorite programming language before Python? Well, there are a couple of candidates, and they're sort of. There was ABC, which I mean, I definitely liked ABC enough to try to recreate it in a different environment. There's C, which I liked enough to use it to implement Python. I also still have very fond memories of Pascal, which was pretty much my first or second programming language, and the one I probably used most while I was in university. That was a very nice language, and it sort of, even though it was designed many years before Python and computers were sort of much more constrained, I think it was actually designed with some of the same ideals of Python in mind, of being simple, but also efficient and practical for lots of different things. I saw you use a Mac. Yeah, that's right. Do you work on Mac too? Well, Python works on Mac. Modern Macs just run some kind of Unix inside, and Python runs. But Python has run on Macs very early on, because the Mac was actually very old Mac was my development machine when I first started writing Python. So I always made sure that it worked on the Mac before I ported it to Unix. Wish you have a good time in China. Yes. It's my first time in Asia, and I really am having a great time here. I'm very touched by seeing what's going on in China. Can we use Python to develop an embedded system? Well, I don't know how you define an embedded system, but this is a cell phone that has a Python interpreter built into it. Yes, and actually any sort of high-end Nokia that internally uses Symbian, or I think S60 is their internal code name, can run Python. Okay, Ruby. This is a good one. This one always comes up. As multi-core CPU architectures become more and more popular, will Python remove the global interpreter lock, or GIL, in the near future? I don't think so. The C-Python implementation just doesn't lend itself to multiple threads accessing the data types that are used to implement Python objects. Now, I'm not worried about that. I think that on multi-CPU machines, if you want to, say you want to run a web server, and you have all 8 CPU boxes or something like that, you can just run one process on each CPU, and it will probably be more effective and more scalable than when you try to use multiple threads. I don't particularly like having to program using multiple threads. Because when 2 threads can interleave in an arbitrary way, like they can with typical operating system level threads, it's almost impossible for the human brain, for even the smartest programmer, to sort of keep track of all the possible interleavings of those 2 threads, and how they, what if this one writes 1 byte, and then that one reads a byte, and then this one writes 2 bytes, and that one reads 1 byte. It's impossible to keep that code right, and every time, whether you're using Linux or Windows or Mac, it doesn't matter. If your machine freezes up, it's probably a race condition where the programmer wasn't smart enough to make the threads work correctly together. So that was the GIL. Plans for performance improvements, and we already had that one. PyPy, I don't know enough about PyPy to give much more of an opinion. I think it's a great research project. I wish they had had twice the funding from the European community, so they actually would have been able to complete it, what they originally were dreaming of. Sorry, this one is a little hard to understand. Oh, okay, this is a good last question. I'm sorry, but what's the official pronunciation of your name? Well, whatever works best for your mouth. My parents called me Guido. That was in Holland, where everybody can say Guido, except my grandparents always said Guido, because that was how it was spelled. Most people can say Guido just fine. In America, people hurt their throat when they try to say Guido. So I changed it to the Italian pronunciation, which is Guido, which in America everybody really knows. And then, of course, you get these strange conversations where people have corresponded with me in email, and then they meet me for the first time and they say, "But you don't look Italian." Well, I can't help it. I don't know exactly what works best for Chinese people. I don't think that I've ever heard a Chinese person say "huh." So I recommend that you say something like Guido or Guido. And I actually respond to anything that has an E and an O in it. If you say, "Hey, Pipo," I'll probably look up. Thanks, everyone.